Yeah, it's like an eureka moment. There's a human behind behind the robot in a way.
Yeah, I think we actually fist bumped at that point. It was just like, it was incredible.
That felt like the hard work finally paid off.
There's kind of 2 or 3 main components. First of which is collecting demonstrations. An expert demo does that. And what we're doing is we're kind of replaying the skill that we want it to do. We are recording the visual data, so coming from our streams of RGB cameras. We're also recording the proprioceptive data about our robot, so the joint angles. They are fed into a model, takes that as input, and as an output, you have an action.
So I'm Siddharth. I'm currently working on the data collection for imitation learning, and I'm also handling the perception tools. It's important to stay focused while collecting data, and it is also important to stay precise, because if me as an expert have to operate the robot to be better than any of the classical approaches, I have to ensure that the trajectory that I follow for the arms are quite robust and quite precise. And I also have to keep it consistent. If I just randomly move the arms here and there, over a period of time, the robot would probably not learn properly, and there would be consequences which would be readily affected during inference.
A challenging task is handling deformable objects, which are classically difficult to model. The fundamental components here is the ability to translate perception into action. And this particular element, which is what we call a large behavior model, is also composed of a visual backbone and an action expert.
The robot primarily adapts using or looking at its visual sensor data, which comes from the RGB cameras. And so it will see where the different positions, where the tower in this case, in this task, is placed. So it might have a different position on the table, it might also have a different pose. And it's using its RGB images to see where it is in real time and adapt its behavior. A well-trained policy is able to interpolate. So let's say there's only seen a handful of positions and orientations. It should be able to interpolate, but it's going to be even better if it's seen a lot more variation. If it's seen a lot more variation in its position and orientation of the towel, it is more likely to be more robust to those spatial variances.
We are able now to teach the robot physical abilities that before only we could perform in a particular intuitive way.